Alright, ladies and gentlemen, nice meeting you one more time again. My name is Tumusima Cohen, your geography paper 1 teacher, what you call physical geography or geomorphology. Last time we talked about a topic on rocks. I went ahead and defined for you the term rocks as an aggregate of mineral particles that make up the Earth's crust. I talked a lot about rocks. For instance, I said rocks are solid, compact, and very hard substances. However, there are also other substances like sandstones, clay, sand, which are also rocks. We went ahead and talked about the different types of rocks in East Africa. For instance, that particular day, we exhausted the igneous rocks, which I'm going to sum up today by looking at the characteristics. Then we can move on to sedimentary rocks and we see how far we shall go. On that very day, I gave a guide question which was talking about accounting for the formation of different rock types in East Africa. And that question was taking 25 marks. So whatever I'm teaching today and whatever I did last time are still answers to that question. With me, I have moved with a pointer, not a cane, so don't fear that I may cane you during the course of this video. No, it's a mere pointer, point at the blackboard. With those few remarks, we can now go on. But before we go on, briefly, igneous rocks, we say that they are also referred to as fire-formed rocks, which are formed due to a process of volcanicity. If you remember very well that video, I drew for you the structure of the earth, briefly, with three major layers of earth: the crust, the mantle, and the core. On the mantle, I dwelt much. For instance, I told you that the mantle contains molten materials. Molten materials, meaning that they are in a semi-liquid state and very hot, moving up to 5,000 degrees centigrade. However, we went ahead and talked about the core, which is more hot than the mantle, and for it goes up to 7,200 degrees centigrade, meaning that the excess heat and pressure from the core will be subjected to the molten rock in the mantle, which will make it melt, boil, generate a lot of convective currents, geochemical reactions. I think about the convective currents in a way that they may be moving towards each other, what we call converging currents, or they may be diverging, what some people call tensional forces. But if they are converging, we are calling them compressional forces. Forcing this magma, the molten rock turning into magma, to be, which may be forced to move up, either onto the Earth's surface or into the Earth's surface. Therefore, we say igneous rocks are of three major categories. One, extrusive igneous rocks, also known as volcanic, formed on the Earth's crust. We also have the intermediate, or in between the volcanic and the last part, the abyssal or plutonic. We have the intermediate. Then we have the igneous rocks which are formed deep or at a great depth, called plutonic or abyssal. Then we say the one in the intermediate is called hyper because it is higher. So we call it hypabyssal. Higher. However, all this depends on the rate of cooling. And we said that the chemical composition also matters a lot in regard to the rate of cooling. Briefly, I talked about silica content. And I said that if magma contains high silica content, there will be quick cooling and solidification, leading to formation of plutonic igneous rocks. While if the silica content is very low, the cooling rate will be slow, forming extrusive, and if the silica content is intermediate, automatically they'll have the hyperbasal or intermediate igneous rocks. You can go ahead and watch that video over and over again. So to wind up this story of igneous rocks, we have the general characteristics of igneous rocks. How do these igneous rocks look like? And at my number one, I have, they do not contain fossils. I know many of you are wondering what fossils are. The word fossil simply means the remains of plants and animals. You have all seen it by yourselves that igneous rocks are being formed through a process of volcanicity where the magma is moving from the mantle interior of the earth's crust, meaning that there is no any plant or animal remain involved, and that's why I'm saying that they do not contain fossils. I have opened the curly brackets for you, and I've said remains of plants and animals. Some books replace these two words, plants and animals. For plants, they put fauna, rather flora, then for animals, they put fauna. I have said for plants, they put flora, then for animals, they put fauna, but still remains fossils or remains of plants and animals. On my number two, or our number two, let me call it our number two because we are me and you, they are crystalline in nature. I know many of you know what to call crystals. The best example of crystals can be salt crystals, they can be sugar crystals, so they are also crystalline in nature. Somebody is asking himself or herself, why is the teacher talking about characteristics of igneous rocks? One day you'll come across a question which reads, distinguish between igneous rocks and sedimentary rocks. And surely this part will help you a lot. Number three, some igneous rocks are hard. For example, granite. Surely, I know many of you have seen diced roads, tarmac. If you look at the tarmac material, they use those small gravel stones, aggregates of stones, or rocks. They are bought from huge granitic rocks, which are exploded using bombs or explosives. 2 days ago, I was interacting with a village, a common person, and he told me, Master, there is a quarrying site around here. I asked him, what do they use to burst those hard granitic rocks? He told me that they use baluti. Now for me, I don't know what baluti means. I told him, is baluti a bomb or explosive? He said, exactly. So it means these rocks are very hard that they must use an explosive to blast them to be able to get small aggregates to construct tarmac roads. So I'm saying that some are hard, some are soft. Not all igneous rocks are hard, but some are hard, some are soft. For example, of pumice, when you move to an area called Kisoro in southwestern Uganda, or Kabale near Lake Bunyoni, you will find a lot of pumice there. Why? They experienced volcanic eruptions some millions of years ago. However, we also have a current example which has happened in this current lockdown, and that is the Nyiragongo volcanic eruptions. You can go there for a tour. If you fear, you can watch on the video or television. Then, They are fire-formed rocks. This is obvious. We say igneous rocks are also called fire-formed rocks. Why? They are formed due to a process of volcanism. Don't be confused of the word vol, V-U-L, and vol, V-O-L. Why? VOL, volcanicity, only deals with extrusive igneous rocks. But for now, we're talking about the entire igneous rocks. And now we're using volcanism, VUL. Why? It combines both. What do I mean? The magma may be forced into the cracks of the rocks, or it may be forced onto the Earth's crust. Meaning that onto the Earth's surface, we are calling it volcanicity. Then into, we are combining the whole process as volcanicity. Then, igneous rocks are fine-grained, small crystals on the Earth's surface. Now, I want us to be so clear here. The fine grains are only on the Earth's surface, not in the interior. Whereas large crystals are formed when in the underground or in the interior. Those are large crystals. For example, granite. Some igneous rocks are spongy. For example, pumice. And this is a result of gaseous eruptions. Now, here is a very simple point. Let me use a day-to-day life. When you are moving with your friends, or you are washing your feet at home, have you discovered some people who have cracks on their legs? I used to interact with my students, and I asked them, how do you call cracks on the legs in your languages? I guess you all have your languages. You know those cracks on the feet, which even can make you buy bed sheets per 2 weeks, because they are very hard and they can crack. Now, there is a simple remedy. When you go to Kisoro, I'm giving examples, Kisoro, Kabale, or when you go to Kenya, around mountain Kenya, or when you go to Kilimanjaro in Tanzania, you will discover that there are some pieces of rocks which have holes on them. And those rocks are very light. They look like real stones you sleep on, and they can be used to clean the legs. I know many of you know them, and I've found them in town and sell. However, I can also give another scenario for you to understand what I mean by these rocks being spongy. When we were in high school those days, they introduced mandazi, which were so big, we used to call them drogba. Now, these mandazis, when you look at them, they could look big when they are going to sell it to you at the canteen. But when you chew once, you could discover a hole in between the mandazi, and you say, take it back. But you've already tested on it. How will they take it back? Sure, it would be funny. But the point is here. I want to compare the mandazi with magma. When the magma is exposed to the great heat and pressure, it is as if the dough or the wheat which you're baking has been put into hot cooking oil. Therefore, the dough will be forced to expand. But as the cooling goes on, the excess gas in the mandazi will move out, then the mandazi will shrink and become too small, and those students will want to buy the canteen. The same applies to the pumice. These rocks are also huge, but because of the too much pressure, after cooling, the gas will get out, and then the small holes will remain. And those stones or pumice are good for cleaning legs with cracks. In my local language, we call them enkiakia. Some people call them moro. I don't know how about you. Alright, so let's leave that alone. I guess you take that point very seriously. Number 8. Some are extrusive This is very simple. That igneous rocks, some, since the magma remains inside the Earth's crust, it forms what we call intrusive igneous rocks. Whereas, due to great heat and pressure, some magma is forced out, it becomes lava, forming what we call extrusive or volcanic igneous rocks. Then, some are light colored. When I say light colored, the opposite is dark colored. Dark colored, they are light colored. And the best example of light colored rocks are granites, like the one they use to make tarmac roads. Actually, these days, I've seen some engineers constructing flats, rather storage buildings, what you call skyscrapers, buildings carrying each other. In simple terms, for layman, there are those small stones they use, and if you look at them, they are not dark but light colored. The best example is granite. While some are dark, there is a rock called gabbro. If you go right now on your Google phone and you put in, how does gabbro rock look like? How does gabbro rock look like in pictures? They will bring you a picture of granite. Then you can say, how does granite look like? They will bring it for you again. You see how it looks like. You will be doing what you call practical learning, and everything will be by your side. Then, that is all I can give for now. But you can go on and do research. You research more and more and more and more about the characteristics of igneous rocks. Now, allow me to start on the second type of rock, and that rock is called sedimentary rock. The word sedimentary is derived from the word sediments. Sediments, meaning deposited material, as we are going to see. Now, sedimentary rocks, I'm writing in my notes here that this is a second category of rocks and are composed of deposited minerals and rock fragments. Rock fragments produced by mechanical and chemical weathering of the former rock masses or by organic action. Let me explain. There is igneous rock already in existence, and the igneous rock is being subjected to different forces. I can use one word: denudation forces. The word denudation forces, let me spell it. Denudation. D-E-N-U-D-A-T-I-O-N. Denudation. Let me repeat. Denudation. D-E-N-U-D-A-T-I-O-N. The word denudation process means all forces acting on the Earth's surface, causing wearing and tearing. So when I say that erosion occurs, you all know what erosion is: the washing away of topsoil from one place to another. But weathering, the rocks, as we shall see in our next topic, weathering, after this rock, we shall see weathering, refers to the disintegration of rock particles into pieces. They can be big or small, depending on the weathering process. But there is a chemistry word we add, and that word is in situ. I don't know whether I'll bring it out very well. Some of you are going BCG. Don't come and kill me if I deceive you, but I won't deceive you. The word in situ means you are not altering, you are not changing anything. The chemical composition is remaining the same, but there is disintegration occurring. Therefore, after these rocks have been broken into small particles or big particles, the weathering geographically or physically. For example, human beings can get materials like a pickaxe. Locally in the land we call it a sururu, a pickaxe. They can break the rocks. Or they may bring a very huge tractor or excavator to break the rock. Or they bring an explosive. Or it can be organic action, as we're saying in the notes here. Organic action. When I say organic, now I'm calling for the role of plants or even animals at some point. And the plants have what we call a root effect. When the roots are trying to expand into the ground, they end up breaking some of these rocks. Ultimately, when I say ultimately, what do I mean? The spelling of word ultimate, U-L-T, then M-A-T-E. Ultimately means as time goes on, continuous processes, the rocks will break into particles. Or the animals have what we call a trampling effect. To trample is to step, to exact pressure, then you break. Now, all those I'm saying about weathering are going to be the next topic of weathering. Don't worry about it. But just know for now that weathering means break down rocks into small particles by either physical processes or organic action. With me here, I have a simple activity or an illustration of how sedimentary rocks are formed. And it heading is saying, Activity 1, an illustration of the formation of sedimentary rocks. In my illustration, I have drawn a piece of rock which looks like a raised land or a high land. And in it, I have labeled it former rock mass. We assume this rock was formed due to volcanicity. I know many of you have covered what we call an iceberg. An iceberg is an isolated hill. You move in a flat area and you find only one hill, but the rest of the land is very flat. You wonder where this one hill came from. And in most cases, that iceberg is also brought in photographic interpretation. And they ask you, how was the future in the middle ground formed? You start by saying, the future in the middle ground is an iceberg. It was formed at first by volcanicity, where the magma moved and remained in the Earth's surface. But later, gravitational processes occurred on the Earth's surface, eroding the softer soils or rocks, exposing the hard rocks, what we're calling igneous rocks. Rather, iceberg, because the iceberg contains igneous rocks. By the way, when you move along Kampala to Gulu Highway, there is a district called Nakasongola. In Nakasongola, there is a place called Sasira, and Sasira has an iceberg. For me personally, I've been there. Or you can move to a place called Mubende. You will see very many icebergs there. Remember, in this paper, Geography Paper 1, you must, I repeat, you must give examples from Uganda, Kenya, and Tanzania. Try to show the examiner you have some knowledge about all the three East African countries, because Job Paper 1 is for East Africa. I know some of you are in SY and you are still confused, because geography has got three papers. Paper 1, East Africa Geography. Paper 2, World Problems and Development. Then paper 3, Ugandan Fieldwork. For paper 3, you only talk about Uganda. But for job paper 1, you talk about East Africa. And please make sure you hit on these examples. So I'm telling you that in this activity of mine in blackboard here, I a piece of raised land, and I'm calling it a former rock mass. Why? That is why at first I began by looking at igneous rocks first, because in the cycle of formation, the rock cycle, igneous rocks are formed first. Meaning that sedimentary rocks are secondary rocks. The word secondary should not confuse you. It just means second time. The first time is primary, like all went for primary, then it came to secondary schools. So, this rock is subjected to weathering. I've told you after rocks, our next topic is going to be weathering. Meaning that if you don't understand this topic very well, weathering will become a problem. Let me also be like a prophet. It is very hard to go for job number 1, section B, and you fail to see a number of roads or weathering. I'm not saying you die on those 2 topics, but it is rare. Don't say I didn't tell you. So, this piece of rock is subjected to weathering. I've told you weathering refers to the disintegration. If the word disintegration is hard for you, you can say the breaking down of rock particles into pieces, which can be big or small, but you add the word in situ. I've told you the word in situ is spelled as I-N-S-I-T-U. It is used in chemistry mostly, and that word means without altering or changing the chemical composition. Well, so after weathering has occurred, there comes in a man you've been looking at since P5, soil erosion. The agents of erosion can be running water, it can be ice, moving ice, what we call glaciers. It can also be wind. Towards the end of this episode or video, I'll talk about the materials deposited by wind, but briefly, materials deposited by wind are called loess. L-O-E-S. I repeat, materials deposited by wind are called loess. L-O-E-S. Materials deposited by moving ice or glacier or fluvial processes. Some people call them fluvial, but for me I'm calling them moraine. I repeat, materials deposited by moving ice or glaciers are called moraine. Then, materials deposited by running water on the surface are called alluvium. Running on the surface are called alluvium. Spelling of alluvium is A-L-L-U-V-I-U-M. I repeat, alluvium. A-L-L-U-V-I-U-M. Also, in the large water bodies, what we call marine oceans and seas, we have waves. I talked about the swash, the wave which moves towards the coastline, and the water which goes back as a back swash. As those waves are moving, the materials deposited are called marine deposits. And that is our interest of sedimentary rocks. So, as you look in my activity here, I've said that erosion of the weathered rock material by agents like water, ice, and wind. Then here I've shown you an arrow and small particles here that weathering of pre-existing rocks being broken down. The most important part is here, that the materials which have been broken down by weathering process are moved down. Let me use the word transport. Are transported down into. Let me now move on here. The weathered materials are transported by erosional agents like water, ice, and wind, and later deposited in strata. The word strata may look new to some of you, but the other word to mean strata is layers. Layers. On either dry land, Now, we go back to our activity 1 here.
We have said that the materials are deposited, but as they are deposited, they appear in different layers, what I'm calling strata. And these layers are separated by a line we are calling a bedding plane, as you can see in our notes there. These layers are formed. After being formed and go on, over time,